Hi, my name is Andy Bays. I am a master's student at San Francisco State University in the final semester of my MS for geoscience. My advisor is Dr. Yadira Ibarra, and the focus of my geoscience MS degree will be in sedimentary geology, specifically a unit of dolostone found in western and central Wyoming. This dolostone is called the Bighorn Formation dolostone, and it was deposited in the late Ordovician, which was approximately 450 million years ago. Directly after the deposition of this particular rock formation, the planet underwent one of the most severe mass extinctions in our planet's history, second only to the Permian-Triassic mass extinction. And also, there was the first glaciation of the Phanerozoic occurred directly after the deposition of this dolostone. And both the glaciation and the mass extinction were triggered by, as of yet, unknown mechanisms, which leads this particular dolostone, the Bighorn Formation, to be of particular interest to science. So the first part of my research, which began when I was an undergraduate, sought to characterize the Bighorn Formation and figure out what was creating these enigmatic structures that are found in its fabric. Previous researchers had concluded, we believe erroneously, that the structures were caused by the burrowing activities of an unknown shrimp-like creature. Through petrographic analysis and hand sample analysis, we determined that the cryptic structures were in fact formed from microbial growths. With this in mind, we concluded that the geochemistry of this microbially created rock must be unique and perhaps contain the original chemistry that was deposited in the shallow ocean, which at that time covered the interior of the United States. So after we introduced a new type of ternary diagram, which proves that the Bighorn was in fact burrowed, and using this ternary diagram that we developed ourselves, we set about to meticulously collect a lot of geochemical data. So why is it important that this particular rock unit was deposited by microbial mats? The reason is because microbial mats, as opposed to burrows, leave open the possibility that the seawater and sediment was in fact anoxic during deposition, which would lead us back to discovering a possible trigger mechanism for the glaciation and mass extinction. Our results are still being analyzed. The geochemistry, that is being analyzed currently, but we do have some results coming back from the geochemistry, namely stable isotopes of carbon and oxygen. We have plotted these in a cross plot, and they end up in the area where modern sedimentary dolomites, that is dolomites that are being deposited in place, they end up in the same type of values that you find for dolomites that are precipitated from microbial growths. Furthermore, we discovered an anomalous correlation between delta C13 and trace metals, manganese, and iron. And the correlation is too great to be explained by mere random happenstance. So our hypothesis is that these microbial mats were in fact leaching trace metals out of the water as part of their metabolic process. As the results come in, we hope to be able to answer the question as to whether the Bighorn Formation was deposited in anoxic and possibly also highly sulfuric conditions. And this would help us to unlock the question as to what caused the first glaciation of the Phanerozoic in one of the largest mass extinctions to ever occur. Thank you very much, ARC's scholarship, for making this research possible.